Hi guys, today I kind of wanted to refactor the GridManager script. It was kind of getting bloated because right now it's holding which unit is being selected. It is checking every frame for mouse click and also being a grid. So there's like three functions for a class, and I think I started scrolling down when I want to find something. That's not really good for a class. So I think it's the right time to separate some of these functionalities to a different class. And I'm glad I caught it early because if it had gone like this for a while more, then it would have been tougher to untangle the class. So the selection manager script is kind of simple, but it does a really important job. It tracks which unit is currently selected. That's it. One field, current, that holds who is picked right now. But the interesting part isn't the field, it's that it doesn't call any other scripts directly. What it does instead is broadcast. There are two events at the top, on unit selected and on unit deselected. When a unit gets selected, the script invokes on unit selected. When something gets deselected, on unit deselected. Whoever wants to react to these events, subscribe from somewhere else. This is called an observer pattern. One class produces events, others listen. The benefit shows up later. Every new feature that should respond to selection becomes a new script that listens to these events. UI panels, audio cues, camera focus, none of them require touching the selection manager again. The pattern is short to write and it pays off every single time you add a new feature because if you change your mind and want to remove a feature in the future, then you can just remove that one script and none of the other scripts or the selection manager will be affected by that. Input controller is just the glitch handling code from before, mostly the same. I just moved it out of the grid manager and gave it its own script. The reason input has nothing really to do with what the grid is. It's just one thing player can do with the grid, so it gets its own home. One small thing did get upgraded though. Before we were checking if a tile was in movement range, I was using Manhattan distance, basically straight line steps without caring about anything in the way. Now it asks the pathfinder, which uses BFS, so it actually respects walls and other units. If a unit's blocking your path, the reachable area routes around them like a real tactics RPG should. The check is just one line pathfinder dot style reachable by, and we send the position currently selected unit and the grid. Otherwise, input controller only handles mouse clicks now. Grid manager only manages the grid. Each one does its job and nothing else. All right, so let's say we got a tile here. Now we are using BFS to find the positions that the unit can move to. So let's add a unit on this tile. So the cost for moving to this tile is going to be 0 as the unit is already there. Now it then checks the four neighbor tiles. So that's this, 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 and this. So the cost for moving to any of these tiles is going to be 1. Then it checks the neighbors of these neighbor tiles. So that's going to be this, this, this for this tile. And the cost is now going to be 2. So 2 here, and 2 here. Now when we get to this tile, since this tile has already been considered from here, we won't uh, look at this tile again because it has already been visited. Now the neighbors of this tile is going to be this and this, and they both have a cost of 2. And same here, let's say we got a movement range of 3. So that's the maximum I can move. So uh, All these tiles gonna have a cost of 3. Remove they. So now that we hit the mobile range, if we try to visit the neighbor of this tile, it's gonna have a cost 4, and that's not valid, so the BFS stops there. So basically, the tiles that a unit on this tile can visit with a movement range of 3 is gonna be this diamond structure. Now, the way the code works, there's a queue of tiles to process. We start by putting the unit's tile in the queue at cost 0. Each time through the loop, we pull out a tile, check its neighbors, and if a neighbor is valid, inbounds, not occupied, and within movement range, we add that neighbor to the queue with the cost plus 1. Cost is just how many steps from the start. Each tile outward is one more step. When we be adding tiles past the movement range, we stop adding them. The queue naturally drains and the loop ends. The big thing BFS does that simple distance math doesn't, it routes around obstacles. If another unit is blocking a path, BFS can't pass through them. So the reachable area isn't a perfect diamond. It's whatever shape the grid actually allows. Now, the script that actually paints the tiles is called RangeVisualizer. And the way it works, when a unit gets selected, this script paints all their reachable tiles blue. When the unit gets deselected, it clears the pane. That's it. But this is the interesting bit. The script doesn't know about clicks or inputs or how selection works. It doesn't ask, was the mouse just pressed or is there a unit at the cursor? It's just listening. Up here at the top in start, it subscribes to two events. Unit was selected and unit was deselected. Those events are broadcast by SelectionManager. RangeVisualizer never calls SelectionManager directly, just waits for the announcement. When a unit was selected, event fires, it asks the pathfinder for units reachable tiles, then paints them. When deselected fires, it clears them. Done. This is called observer pattern. One class announces stuff, other listens. The advantage is RangeVisualizer can be deleted entirely from the project and nothing else breaks. Selection still works, movement still works. The blue pane just doesn't show up anymore. One little detail on destroy, I unsubscribe from the events. If you forget this, destroyed objects can still receive events and cause weird bugs. The grid manager is still here, but it's much smaller. What it does is generates the grid when the game starts, holds the data, which tile is at which coordinate, what game object represents that tile in the scene, lets other script ask questions about it, uh, like what's at position 3, 4, what are the neighbors of this tile, is this position even on the grid? That's it. No input, no selection, just the grid as a thing that exists and can be queried. The methods are all small: grid to world and world to grid, convert between grid coordinates and world coordinates, get tile and get tile visual, look things up, get neighbors, returns the four orthogonal neighbors of any tile. That's what BFS uses to walk the grid. Isn't bounds is a quick check that coordinate is valid. Nothing complicated. The file kind of used to be twice this length, and most of that was code that didn't really belong here. Now it does one thing, and it does that really well. Now in here, I've added more empty game objects and attached corresponding scripts to it. So the selection manager, range visualizer, and input controller. And if I hit play, I've also like renamed the capsule to red, blue, and green. So right now red has a movement range of 5, and if I select uh, the maximum, it can move to its 1, 2, 3, 4, and 5. So that's the That's when it hits the movement range cap. And for blue, I've set it to 4. There you go, 1, 2, 3, and 4. And for the green cap 0, I've set it to 3. So that's kind of how the BFS is working right now.